Hi everybody. So in these types of videos, what we're going to be doing is I'm going to be basically laying out, kind of giving you a sneak peek of what we're going to be doing in class when you come into class. So the first thing I want to talk about is when you take a look, it says find the value or find, and then we have f of 2. So let's talk about what this means. Well, when we think about the f of x notation, the input is the x value inside the parentheses right there. And what we get out is the y value. We kind of think of a function like a machine where you have an input and then you get an output. So when we take a look at this one, it says find the f of 2. Well, that would be when the x value is equal to 2. Where is that? Well, if we go on the x-axis, we're using this graph right here. And the x value is 2 right here, right? That point isn't on the graph, but we can see that that is the point 2, 1. And what that means is that if you plug 2 into the function, we got a x or a y value of 1. So the f of 2 is equal to 1. Now this next one says for which values does the f of x equal to -2. So when we take a look at that, this -2, think about that. Is that an x or a y value? So that seems to be a y value, right? Because if we take a look up here, we can see that the f of x is equal to y. Now look at this graph. Where is the y value a -2? Well, it's this line right here is y is equal to -2. So where does that cross? It seems like it's right here. Now we don't have an exact number for that. It seems like it's somewhere between -4 and -5. So I'm going to say x is probably equal to something close to, let's say, -4.3. Just doing our best guess here. We'll learn some algebraic techniques to try to find exactly that value, but for right now, that's the best we can do. The next one says, what are the x-intercepts? Remember, x-intercepts are where the graph crosses the x-axis. I'm going to use a different color for that, but you can see it crosses the x-axis here, and it crosses the x-axis here. So the x-intercepts would be x is equal to, what is that x value at that first one? It's -3. We can see that right here. And then the other x-intercept is going to be at 0. So it seems like we have x-intercepts at -3 and 0. So if an x-intercept is where it crosses the x-axis, the y-intercept is where it crosses the y-axis, right? And we can see that here's our y-axis right here, and it crosses right here. So that's also, the y-intercept is also x equals 0. That's because it goes through the origin, so it's both an x and a y-intercept. All right, I'm going to clear this out because now we're going to talk about where the function is increasing. For a function to be increasing, what I like to think about that is when you read a book, do you read a book left or right, correct? So when we read a book left to right, we're going to think about where is this graph going up? And I'm going to use this color right here. We can see that on this interval right here, this is increasing, right? Where else is it increasing? It's also increasing on this interval right here. So how would we determine that? When we talk about increasing and decreasing, we're only talking about the x values. This is going to be difficult to kind of wrap our head around, but we're going to think about this. On this number line, if I look at this like a number line, where we've got 0 here, we've got -infinity out here, and we've got +infinity out here. Where is this increasing? This is increasing this entire way up until this point, which is -3. And then there's this little piece here. That's not increasing, is it? We'll talk about that in a second. But then it starts increasing right here again at -2, and it seems like it increases forever. So when we look at what I shaded, it looks like it's increasing from -infinity to -3. And to say and, we use a union symbol. It looks like it's increasing from -2 to infinity. Notice I always use round brackets here for this set notation. If this set notation is new to you, I strongly encourage you to come talk to me about this in class so that we can go over that. But the intervals where the function is increasing is -infinity to -3, union, or and, -2 to infinity. All right, so I'm going to clear this out, and we're going to do decreasing now. So let's take a look. Where is this graph decreasing? I'm going to use a different color for that. Let's use this green right here. This is where the function is decreasing because you can see it's going down. As we go left to right, the function is decreasing. And that's, again, we just talked about the x intervals. It's -3. And then where does it stop decreasing? At -2. And that's the only place where this is decreasing. So this is -infinity. I'm sorry. Where is that decreasing? It's decreasing from -3 on the x values, and it stops decreasing at -2. Now, what's the domain of this? When we think about the domain, we think about all of the x values. If we had an equation, we might think about this in some algebraic language, but if we're just working with a graph here, take a look at these. This has an arrow on it. This has an arrow on it. We're going to assume that. So it looks like this is going to go all the way from the left to the right. So there is no breakpoints. There is no holes. There is no jumps. So the domain of this is -infinity to +infinity because the domain is the x values. Similarly with the range, now we're going to think about how high and how low this graph goes. This looks like it goes down forever, right? And it also looks like this graph is going to increase up forever too. So the range is also -infinity to +infinity. Now, one thing we want to make sure we note, this is not always going to be the case. The domain and range are not always going to be -infinity to infinity, but since this one goes left and right forever, and it looks like it goes down and up forever, that's why our domain and ranges are -infinity to +infinity. Another way we say that is all real numbers. All right, the next thing we're going to look at here is maximums or minimums. Any relative maximums or relative minimums. A relative maximum is where all the points around it are less than that. And when you take a look at right here, you see that everything below it, or everything on the right and left is below it. So this is what we would call a relative maximum. So what we would say, there is a relative maximum of 0 at x equals -3. The maximum or minimum is the y value, and then you tell me where it's located by an x value. Is there any relative minimum? So let's go back. This is a max. We'll say a relative max. Is there any relative minimums? Look at the graph and see if we can figure this out. I'm going to give you a second to think about it. Well, I think indeed there is one. When you take a look right here, you can see that everything on the right or to the left of it is above it. So would we also say there's a relative minimum of, what is this minimum value? -1 at x equals -2. The last thing we're going to take a look at in this video is whether there are any absolute maximums or absolute minimums. Now, an absolute maximum or an absolute minimum is where everything in the graph is below it or above it. And we can see that since this graph looks like it's going to be continuing this direction and this direction forever, this is going to go up forever to +infinity, like we said in our range. And it's going to go down forever to -infinity, like we said in our range as well. So we would say no absolute max or mins.